let's look at this Khan Academy dependent probability assignment together. Captain Jessica has a ship, the HMS Crimson Lynx. The ship is 2 furlongs from the dread pirate Ishan and his merciless band of thieves. If her ship hasn't already been hit, Captain Jessica has a probability 2/5 hitting the pirate ship. If her ship has been hit, Captain Jessica will always miss. If his ship hasn't already been hit, dread pirate Ishan has probability 3/8 of hitting the captain's ship. If his ship has been hit, dread pirate Ishan will always miss. If the captain and the pirate each shoot once and the captain shoots first, what is the probability that the captain misses the pirate ship but the pirate hits? Okay, so the first thing we're looking at is the captain missing the pirate ship. So let's say, I'm just going to write out something. So misses the pirate ship, because that's what's happening first. Writing with this little tool they have is tricky. So, misses the pirate ship. If the ship, okay, so the captain's going to shoot first. And so the pirate wouldn't have already hit, right? So if her ship hasn't already been hit, Captain Jessica has a probability 2/5 of hitting the pirate ship. So, what is the probability that the captain misses the pirate ship? Because she won't already be hit. So there's a 2/5 probability of hitting it, a 3/5 probability of missing it, right? So 3/5, her ship hasn't been hit yet, so she has a 3/5 probability that she's going to miss it. But then the pirate ship is shooting after that. What's the probability that that's going to hit? So if his ship hasn't already been hit, dread pirate has probability 3/8 of hitting captain's ship. If his ship has been hit, he'll always miss. Okay, so we're assuming that the captain misses. So that means pirate Ishan has 3/8 chance now of hitting Jessica. So that's not supposed to be an equals, it's supposed to be a times. So we're going to take the probability that Jessica misses times the probability that the pirate hits, and we get 9/40. Let's check that answer. 9/40. Check. Woohoo! In a class of 7, there are 5 students who forgot their lunch. If a teacher chooses 2 students, what is the probability that neither of them forgot their lunch? So there's only 2 that remembered their lunch, right? So if the teacher chooses 2 students, the probability of picking one of the 7 that didn't forget their lunch is 2 out of 7. Okay? But then once the teacher has chosen one person, if the one of the ones that hasn't brought their lunch was chosen correctly, now we only have 1 student out of 6 who has forgotten their lunch, or who hasn't forgotten their lunch, because 5 of them did. So 2 didn't forget their lunch out of 7. So there's the chance of picking 1 student. And then after that, we know who the 1 is. So then there's a 1 out of 6 chance of finding the last one that didn't bring their lunch. So that should be 2 out of 42, which would reduce to 1 out of 21. But I've discovered that this program doesn't care if you reduce your fractions. So I'm just going to try my 2 out of 42. And I got it. I'm assuming that 1/21 would have given me the same positive result. A bag contains 2 red marbles, 3 green marbles, and 4 blue marbles. If we choose a marble, then another marble without putting the first one back in the bag, what is the probability that the first marble will be green and the second will be red? So the probability that our marble is going to be green is 3 out of 5 plus 4, 9 total, correct? So the first one is going to be green. That would be a 3 out of 9 chance. So now that marble is not going back in. So we're going to find the chance of getting the second one is red, but now we're down to only 8 marbles. We've taken out a green one, and so there's still 2 red marbles left. So there's only 8 marbles, so 2 out of 8 chance of getting a red one. So now we multiply these together, so we get 6 over 72, which I believe reduces to 1 out of 12. So I could type in 6 divided by 72 or 1 divided by 12 and check my answer, and I've got it. Ooh, here's another lovely captain and pirate ship problem. Captain has a ship. The ship is 4 furlongs from the dread pirate Michael. If the ship hasn't already been hit, Captain Ishan has the probability 2/5 hitting the pirate ship. If his ship has been hit, he will always miss, so that's a probability of 1. If his ship hasn't already been hit, dread pirate Michael has the probability 3/8 of hitting the captain's ship. If his ship has been hit, dread pirate Michael will always miss, so that's a probability of 1. If the captain and the pirate each shoot once and the captain shoots first, what is the probability that both the captain and the pirate hit each other's ships? Okay, so if the captain shoots first and he has a 2/5 chance of hitting the pirate ship. So 2/5 chance of hitting the pirate ship. Then the pirate, having been hit at a 2/5 chance, now has a 0% chance that they are going to hit the captain because they're not going to hit it. They'll always miss if they've been hit. So I'm pretty sure that gives us a 0 probability of them both hitting, because either one's going to hit and the other miss, or one miss and the other hits. And so it's a 0 chance that they're both going to hit. So that's tricky, right? I got another problem similar to one of these before, where it actually said what are the chances that they're one is going to miss, and so then the other one is going to miss. I can't remember what this was exactly, but don't forget that if you need to include the probability of missing, that probability would be 1. And so multiplying that in doesn't change the value that was already determined. So for example, if we wanted the probability that the captain Ishan hits the pirate, then that would be a 2/5 chance. But then the probability that the pirate doesn't hit the captain, that would be a 100% chance. So we would take like 2/5 times 1, and that probability would be 2/5.